Hello everyone, welcome back to the channel. Today we are going to solve this question. The name of the question is count number of pairs with absolute difference k. Okay, now let's read the question. The question is given: we have an integer array called nums and an integer k. Okay, so we have to return the number of pairs. Okay, ij, number of pair ij where I is less than j, such that nums of I minus nums of j is equals to k. What does that mean? Okay, we have a modulo also. We have a modulo of nums of I minus nums of j. That means we'll always get a positive number. We'll always get a positive number. Okay, now we are given this nums array. Okay, so how many variables, how many pairs would be equals to I minus j mod, where j is greater than I? Okay, now let's see we have 1 2 2 1. We have 1 2 2 1. Okay, now at index 0 we have our variable I. At index 1 we have our pointer j. Now j means 1 is greater than 0. This value satisfies j is greater than 0. Now nums of I minus nums of j, that means nums of I 1 minus 2 and their mod will give 1 minus 1. 1 minus 2 will give minus 1 and its mod will give 1. That is equals to k. Yeah, k value is equals to 1. Now k, we have the value of k to be 1 and that is equals to k. So we will increment our counter. Okay, that means we got one pair. Okay, so increment our counter variable. Counter is counting total number of pairs with their difference as this value k. Okay, now j goes here. Now we'll check I minus 2 means 1 minus 2 will again give this one. So again we got one more pair, so we'll increment our counter to 2. Now j goes here. Now we'll check 1 minus 1 will give 0, so that is not equals to 1. Okay, now again we increment our I at index 1 and j would be equals to greater than I. J will be equals to greater than I. Now check 2 minus 2 0, not equal to k. 1 minus 2 2 minus 1, 2 minus 1 will give 1. So again we got one more pair, so we got total of 3 pairs till now. Now j was here. Now it is at the last of the array, so again we will increment our I and j is here. Okay, means I plus 1. Now we'll check 2 minus 1, array of I minus array of j will give again 1. 2 minus 1 will again give, that is equals to k. So again we got one more pair, so our answer is equals to 4. Because after that if I goes here, then we have no more variables that belongs to I plus 1. There is null here. Okay, null variable, so we cannot go more beyond this value. Okay, so till now our answer is 4. So you have got one intuition that we are using two for loops, because once I was here, j was traversing whole array, leaving this value, leaving this I. When I got here, j was traversing from here to here and was cross checking is to I minus j equals to k, I minus j equals to k. Okay, so we have a nested loop. Either we can take a while loop or a for loop. I am going with the for loop. So we have two for loops and each time we find k, means I minus j equals to k, will increment our counter. At last we will return the counter. So this one, okay, let's discuss the time complexity of it. Also time complexity, we have two for loops. First one is running n times, second one is running n minus 1 times. So it is n into n minus 1, very good, yeah, n minus 1, which is obviously equals to big O of n square. big O of n square, and space complexity is obviously big O of 1, big O of 1, but the time complexity is not optimal. Okay, first of all, let us discuss the code. The code would be, we'll run 2 times now, equals to 0, I less than nums length and I plus plus. Now we'll run the another for loop for j from I plus 1, j less than nums dot length and j plus plus. Now we'll check if this condition, nums of I minus nums of j and their mod, okay, and their mod, if mod of nums of I minus nums of j is equals to k. If it is equal to k, we will increment our counter plus plus. Okay, we haven't declared our counter, and counter equals to 0. At last we will return counter. Okay, so that will run, I guess. It may give TLE sometimes. Okay, it's running, I guess it will submit also. Sometimes it might give TLE. Okay, right now it's running, but see, we have 8 ms and only 53% of acceptance, so it is a very bad, it is very bad. We should take about 3 or 4 time only, 3 or 4 ms. Now what we will do so here we are given this condition, nums of I minus nums of j equals to k. Okay, I will take nums of I as I, nums of j as j is equals to k, and their mod is equals to k. Okay, now if we open the mod, according to mathematics, we can get I minus j is equals to k, and I plus j is equals to k. Now y plus, when j is less than 0, when j is negative, and y, this one, when j is greater than 0, then this value. Okay, that is the property of modulus. Okay, now how we can write it, we can write either we will get sorry, or we can reduce it like this, uh, j is equals to I plus k or I minus k. Okay, that is also correct. Okay, just we have put I there, and j will get this negative value. Okay, yeah. Now if we have this one like j is equals to I plus minus k, this is our condition. Okay, now we have the array 1 2 to 1, we have the array 1 2 to 1, we have the array 1 2 to 1. Okay, now if we traverse here, from here, okay, I minus k, what is the value of k? K is equals to 1. 1 minus 1 is equals to 0. Okay, is equals to 0. Do we have any value that is equals to 0 here? No. Again we will traverse here. Okay, now we'll check 2 minus 1, 2 minus 1 will give, sorry, one thing we forgot, 1 minus 1 equals to 0, and 1 plus 1, because one time we are doing subtracting and one time addition, so 1 plus 1 will give 2. Okay, have we visited 2 when we were here? We haven't visited any other element other than 1. So right now both 0 and 1 are not visited. Okay, are not visited. Okay, when I goes here, we'll see 2 minus 1 will give 1, and 2 plus 1 will give 3. So any of them, either 1 or 3, have we visited? Yeah, we have visited once. 1. So we will increment our counter. Why? Because we have got the j, and that will satisfy this equation. Means j value is equals to 1 and 2, so we'll get 2 minus 1, or sorry, 1 minus 2 will equals to plus minus 2 plus minus 2. Leave it. 1 minus 2 mod equals to k, that is equals to 1 equals to k, that is equals to 1. Okay, so in this condition we are incrementing our counter value to 1. Yeah, now we don't have 3. For 3 we are not incrementing, for 1 only we are incrementing. Okay, now 1 goes here, 1 goes here. Okay, so till now we have visited these 2. Now we got 2, again we'll get this condition, and we have 1 again, so again we will increment 1. Why again 1? Because 2 minus 1 will give 1, and 2 plus 1 will give 3. So we don't have 3 visited only, we don't even have in our array, so we have only 1, and 1 is visited, so we'll increment our counter to 2. Now I goes here, I goes here, now this one is also visited. Now we'll check. I minus 1, it gives 0, and I plus 1 will give 2. Okay, so is 0 there in our array? 0 is not there, so there is no chance we get any counter variable value for this. Now do we have 2? Yes, we have 2. And how many times 2 is appearing? 2 times. That means we got 2 pairs, when one with this one and one with this one. Okay, we got 2 pairs, so increment our counter to 2 times, means 2 plus 2 equals to 4. So this is our, I think this 4, yeah, 4 was our answer. We got 4. Okay, so for that, but we need to check if 2 is visited or not. But how we will check if 2 is visited? Also we need to check if 2 is present one time or two times. See, in the last condition we saw that 2 was present, but 2 had the frequency of 2, means it was appearing 2 times. So we are adding, actually we are adding its frequency. See, 2 was present 2 times, and it was also visited 2 times, so we were incrementing its value to 2 with 2. So 2 plus 2 would give 4. Okay, so how would we do that? One condition is that we can use a frequency array. We can use a frequency array. But what if these values do not lie between 0 to n? Okay, then we have to use a very big counter, a very big this our frequency array 0 to integer dot max value, integer dot max. Okay, so what we can use this one also. This one also will give the correct answer, and but right now I'm using a map of element. It will contain an element and its frequency. Okay, I'm using this, both are of value integer. Element and frequency both are of both are of integer types. Okay, now let's check what we are doing. First of all, we have a counter and a map. So we'll have counter, sorry, counter equals to 0, and we'll have a map integer map equals to new hash map, and will traverse one time, so that, okay, now discuss the time complexity. See, we are traversing just once, see, only once. And here what we did, we were traversing two times. See, I came here, I again here, again j was traversing two times, means n cross n times. Okay, and it is just linearly traversing, so we have our time complexity to be big O of n. And space complexity, we are using a hash map, so again space complexity will increase to big O of n, but it is more optimal than the previous one. Okay, now let's code it up. We'll have a for or while loop. I'm using for loop int I equals to 0, I less than nums dot length I plus plus. Now we'll check. What we will check, if I plus 1, sorry, I plus k or I minus j. I plus k or I minus j is present or not. We'll check. If, let's name it as frequency. If frequency contains I minus k, nums of I minus k, if it contains, so what we will do, we will increment the number of times it's appearing. That means we will increment by its frequency, like here we are incrementing by its frequency number. So we'll get its frequency number. Counter plus equals to frequency dot get nums of I, nums of I minus k, okay. And one more condition we are having, that I minus k, if frequency contains nums of this one was I plus k, plus k and I minus k, it will be I plus k. Okay, let's take I plus k here, I plus k again, I plus k. If we have this, again we will increment our counter, I plus k. And at last we have to update our map also, na, because we are traversing at 1, we didn't have any of this value, but when we went to 2, we have this value in our map. Okay, so in each iteration we are incrementing, or we are putting up the values in our map, putting the previous value that are visited. Okay, so we'll put the values that are visited, that means current value will put. So we'll put frequency, put the current value, which is the current value, nums of the current index, and we'll increment the frequency. Okay, frequency, if here the frequency of 2 was 1, now when we got here, we had the frequency already as 1 now, but we visited this one, so now we have to increment to 2. Now it will get to the 2 is appearing 2 times, so we'll increment frequency dot get or default. This method is used to get the default frequency that is present, and nums of I yeah, nums of I plus 1. Okay, so sorry, if the default value, if no default value is there, we will put a 0 and increment with 1. Okay, at last we will return our counter. Okay, let's try run again. See, we have 1 2 3 4. At 1 our map is empty. Okay, so we will increment, just we'll put it in our map, and its frequency is 1. Okay, at this 2 we have just 1 with frequency 1, and we'll check 2 plus 1, or 2 plus 1, this k is equals to 3. 3 is not present here, and 2 minus 1 gave equals to 1. Yeah, so we have 1. What was the frequency? 1. So increment with 1. So right now we have 1. Now I goes here. Okay, before that we will increment our counter of 2. Okay, we have 1 comma 1, and now we have 2 comma 1. Now when we visited this one, we check 2 plus 1, 3. 3 is not present. 2 minus 1, we have 1. Okay, we have 1. Its frequency is 1, so again increment it with 1, so it's 2. counter is equals to 2. Now we will put this 2 in our map. Before that we will check its frequency. Its frequency is 1, so we'll increment it with 2, means 1. So now our incremented frequency is 2. Now I goes here. Now we'll check 1 plus 1 is 2, so 2 is present there. Yeah, 2 is present, 2 is present, and its frequency is 2, so add 2, it will be 4. Now 1 minus 1 is 0. Okay, 1 minus 1 is 0. Is 0 present? No, 0 is not present, so our final value is 4. So we have also tried run the code. Okay, so most probably this will run. This indeed will run. Yeah, it will run. And see, 0 time. See, 4 millisecond, that was taking about 8 millisecond. This one is 4. So this one is an optimized solution with time complexity of big O of n and space complexity of big O of n. Okay, so that was all.